So we're about to launch into a whole long series of lessons that talk about the operators in single and talk about the operators in observable and talk about the operators that exist with flowables and parallel flowables and so on. But to do that, we're going to use a case study, or case studies. And I want to give you an overview of the case studies before we dive into the different examples, so you'll have the big picture view of what we're trying to do. The case studies are all going to end up working on these things called BigFractions. I think we've talked about BigFractions before. The BigFraction class is a class that does arbitrary precision fraction arithmetic, and it uses big integers for numerator and denominator, which means you can have arbitrary precision. They could be infinitely big, well, not infinitely, but very, very, very large fractions. Some of the methods in BigFraction are used to reduce fractions. So if you give them 44/55, you can reduce it to give you 4/5, and so on. Hopefully you remember that from like 4th grade or 5th grade math. There's also factor methods that create non-reduced fractions, and then factor methods that reduce them. So if you create one and say, I don't want to reduce this one yet, and I'll explain why you wouldn't want to reduce one necessarily, you can create an unreduced big fraction, and then later you can reduce it. And the main reason you'd want to do that would be if it takes a while to do the reduction, because a very large big fraction will take a while to reduce, you might want to do that off the main thread. You might want to do it in the background somewhere, so you can take advantage of cores. The other things you can do with big fractions is you can perform arithmetic, like you can multiply big fractions together, you can add, subtract, divide, and so on. You can also take a mixed fraction. You can create a mixed fraction from a so-called improper fraction. I always thought that's a funny name, but this is an improper fraction, and this is a mixed fraction. I guess it's also a proper fraction, although the word mixed fraction seems to come along a lot more. So 18/4 is 4 1/2. So that's an improper fraction. 18/4 is improper, and 4 1/2 is a mixed or proper fraction. All right, so given all that, we have a bunch of case studies that we're going to look at. I think there's probably 4 or 5 of them. And they're going to demonstrate how these different RxJava features can be applied to do manipulations on big fractions. And honestly, who cares that much about big fractions? It's just a way to show off all these features in a way where we can do apples-to-apples comparisons. So if you don't like big fractions, think about something else you'd want to compute in parallel, like, I don't know, trying to break encryption or computing some value for a data science model or whatnot. So we've got a bunch of case studies that work on single classes, the RxJava Single class, and it shows off a whole slew of cool singles methods. And what's kind of fun, when we do the singles analysis, you'll see that a single is quite a bit like a completable future. So a lot of the stuff that you've learned from completable futures applies pretty nicely to understanding the way that singles work, with a few little tweaks. And the biggest tweak is that unlike completable futures, which are inherently asynchronous, there's no 2 ways around it. Completable futures are going to be asynchronous unless you're doing something really bizarre. In contrast, singles don't have to be asynchronous. They often are, but they don't have to be. And if you want them to be asynchronous, you need to use an operator here. It's a scheduling operator where you schedule the computation to run in some background thread. And that's very flexible. It's very convenient. It's kind of like using supply async with some custom executor. But it's a little bit more verbose. And so that's one of the things you'll probably notice is that if you compare and contrast RxJava Single code with completable future code from modern Java, the Single code is a little bit more verbose than the completable future code. We also have another little batch of case studies that show how to use RxJava observables to create, reduce, multiply, and display big fraction objects using piles of features on Observable, and there's a whole bunch of them, as you can see here. Once again, the way to think about this at a high level is kind of like taking sequential streams and completable futures and then defining a programming model where we sort of bake the semantics into one programming API as opposed to having to combine 2 APIs. Once again, you'll see that it's a little bit easier, like actually a lot bit easier to use parallel streams in order to make something run concurrently, because you just replace stream with parallel stream. Whereas with observables, it's a little bit more ceremony to do this. Now, the benefit is you can get asynchronous computations with reactive streams, with RxJava observables, whereas with parallel streams, you're kind of stuck with synchronous communication. So there's pros and cons. And there's also just a more consistent programming model with the reactive streams approach. And then the third set of case studies we're going to look at, and there probably won't be as many of these, but there'll be at least one, because you'll need to know how to do this for your assignment, 4B, will be showing how to create, reduce, multiply, and display big fraction objects using flowable and parallel flowable features, especially the parallel flowable part. And a parallel flowable is a really clever way of being able to do a bunch of computations in parallel without having to have a whole lot of idiomatic code patterns that are a little bit obscure. In particular, not to get too far ahead of ourselves, this is code that does processing with what's called the flat map concurrency idiom. And you can run some computations concurrently. But it's a little bit crufty to do it this way. This is the code that does it with a parallel flowable, which is just less complicated once you understand what's going on, and scales up very nicely. So parallel flowables are actually quite a bit like parallel streams, and they have a lot of the same benefits, but again, it's an asynchronous reactive model as opposed to a synchronous model. So that is a quick overview of the big fraction case studies. Now we're going to turn our attention in just a moment to the more detailed coverage of the operators in the different RxJava classes in the context of these case studies.